Back in 1905, in the mind of a young patent clerk named Albert Einstein, a storm was brewing, a storm of thought. And what came out of that storm wasn't just a new theory. It completely rewrote our understanding of the universe itself. Okay, let's get right into it.
And this one idea, this special theory of relativity, just turned everything on its head. I mean, everything we thought we knew for sure. Space, time, matter, energy, it was all up for grabs.
So how on earth did he figure this out? Well, we're going to follow his journey. We'll start with the world as we see it every day, our common sense world. Then we'll introduce one very strange fact about light. And from there, we'll watch as time and space literally begin to bend, revealing this incredible fabric of space-time and ultimately a whole new view of reality. To really appreciate just how radical Einstein's idea was, we have to start with our own gut feelings, the common sense world that we all live in every single day.
This seems totally obvious, right? So imagine you're on a boat, and it's chugging along at 10 kilometers per hour. Then you decide to drive a little car on the deck of that boat at 20 kilometers per hour, going in the same direction. Well, somebody watching from the shore would see that car moving at 30 kilometers per hour. You just add them up. Speeds are relative. That's how we think the world works.
But here is the twist. The one simple but completely world-changing idea that breaks all of those common sense rules. It is the key that unlocks Einstein's universe, and it's all about light.
This is where our brains start to feel a little bit fuzzy. Our intuition, our common sense, tells us that if you run towards a flashlight beam, it should seem like it's coming at you faster, right? But what Einstein realized, building on the work of others, is that this just isn't true. The speed of light is absolute. It is the same for every single person, no matter how fast you're moving. It's a constant.
And that speed is just staggering, about 300 million meters per second. But you have to understand, it's not just a number. It's the cosmic speed limit, a fundamental rule of the universe. And if this one weird fact is true, well, reality has to get very, very strange to make it all work.
So here's the crucial leap. If the speed of light has to be constant for everybody, no exceptions, then other things that we thought were constant, like how time flows or how long a meter stick is, they can't be. They actually have to stretch and shrink to make sure that cosmic speed limit is never, ever broken.
You see, accepting light's constant speed is like tipping over the first domino. It starts a chain reaction that knocks down three of our most basic ideas about how reality works. So let's take a look at each of these consequences, one by one.
Okay, first up, the very idea of now. We all assume that if two things happen at the same time, that's just a fact for everyone, everywhere. But Einstein showed, nope, what's simultaneous for me might not be for you if we're moving differently.
And he had this amazing thought experiment to show it. Imagine a flash of light goes off right in the middle of a moving train car. For someone sitting on that train, the light travels an equal distance to the front and the back, so it hits both ends at the exact same time. Simultaneous. But for someone watching from the platform as the train zooms by, well, the back of the train is moving away from the light pulse that's chasing it, and the front of the train is moving toward its light pulse. Since the speed of light is always the same, the light hits the front first. The events are not simultaneous. So who's right? The wild thing is, they both are. Your now literally depends on how you're moving.
The next domino to fall is a big one. It's time itself. This is what's known as time dilation, and it's the idea that the faster you move through space, the slower you move through time.
And this isn't just some wacky theory. It's real. We've measured it. Astronauts whizzing around on the International Space Station are moving so fast that they actually age just a tiny bit slower than us down here on Earth. The effect is real.
To help us wrap our heads around why this happens, Einstein came up with a brilliantly simple idea, a light clock. All it is a particle of light, a photon, bouncing between two mirrors. Every time it makes a round trip, tick, tock, that's 1 unit of time. Super simple. Now check this out. When the clock is just sitting still, the light has a short, straight path up and down. Easy. But if you're watching that same clock move past you, the light particle now has to travel a longer diagonal path to get from one mirror to the other. But remember the one unbreakable rule. The speed of light is constant. So if it has to travel a longer distance at the very same speed, it must take more time. The tick of the moving clock is slower. Time itself has actually slowed down.
Okay, so if time can change with motion, what about space?
Well, to keep that cosmic speed limit for light constant, which remember is distance divided by time, if time is changing, then distance, space, it has to change too, just to balance the books. It has to shrink.
This is called length contraction, and it means that an object moving at a really high speed is physically shorter in its direction of motion compared to when it's at rest. It's not a trick of the eye. From your perspective on the sidewalk, that speeding taxicab has actually gotten shorter.
So we've got time slowing down, space shrinking, the idea of now being relative. Are these just a bunch of separate, weird effects? Not at all. Einstein showed that these are all just different symptoms of a much deeper, unified reality.
And this is a really cool way to think about it. Imagine that everything is always traveling through a single, four-dimensional fabric called spacetime. When you're just standing still, you're using your entire motion budget to travel through the time dimension. But the moment you start walking, you divert some of that motion into the space dimensions. And the result? You have less motion left over for the time dimension, so your personal clock ticks a little bit slower. It's all a cosmic trade-off. And now we get to what is maybe the most profound and mind-bending implication of this whole thing. If we accept that time and space are woven together, and that our experience of now is just a matter of perspective, it forces us to completely rethink what reality even is.
Seriously, think about this. My now might include events that for some alien on a super-fast spaceship far away are already in their deep past. If that alien turns around and heads toward me, their now could contain events that are still in my distant future.
So here's the kicker. If my past can be someone else's now, and my future can be another person's now, it suggests that all those moments are just as real as this one. Relativity points towards this idea of a block universe, where the past, the present, and the future all exist together, all at once, laid out like the frames of a movie.
And that leaves us with this final, truly staggering thought. That feeling we all have of time flowing, of the present moment moving from past to future. What if that's just an illusion, a trick of our perspective? The storm in Einstein's mind didn't just give us new equations. It revealed a universe far stranger and more beautiful than we ever imagined. One where all of time might exist right now.